Hello, I welcome you to this short video where we want to look at the question based on the concept of matrices. So the question on number 1A says, given that matrix L equal to, as we can see the matrix with the following elements, and matrix M equal to this, find 1, the value of x for which the determinant of matrices L and M are equal. So there lies the key word. Determinant of matrices L and M are equal. Okay, so we are going to use that to find the value of x. And how do we do it? So we understand that when finding the determinant of the matrix, let's say in this case we have the matrix L, so we are going to say determinant for the matrix L is equal to, so we multiply the major diagonal, its product, we are going to subtract. We subtract the product of the minor diagonal. So we are saying determinant of the matrix L is equal to -2 times 7 minus the other part for the minor diagonal, it is 6 times -2. So this is for the matrix L. Let's finish it up. So this is going to give us -14 minus -12, which shall come to -14 plus 12. And finally, this will give us -2 as the determinant of the matrix L. Coming to the other matrix, which is matrix M. So its determinant, we are going to say determinant of M is equal to, so we do the same, the product of the major diagonal, so it's x times 2 minus the product of the minor diagonal. So we are going to say -3 times -4. So this will come to x times 2, we get to x, then we have a minus here, -3 times -4, we get 12. So there's a minus here, so it will be -12. So this is going to be the determinant of the matrix M. Now, we understand that this determinant of M is equal to the determinant of L. So we can equate the two parts in order for us to find the value of x. And because the question is about x, I would rather begin with where the expression where we have x. So I'm going to say 2x minus 12 is equal to -2. And then this shall come to 2x is equal to -2. Then we bring the additive inverse of -12, which is +12. So this will come to 2x equal to -2 plus 12 will give us +10. So we can simply now divide on both sides by 2, and we can say therefore x is equal to 5. So this is the value of x. I hope we are together on that one. So that is for the first part of the question. Then the second part is asking that we find the inverse of the matrix L. So how can we find the inverse of the matrix L? So we understand that for this part of the question, we want to find L inverse, okay? And for L inverse, we understand the formula is that it should be 1 over determinant of the matrix L times the adjoint of the matrix L itself. Okay. So we already know the determinant of the matrix L. So what is needed is just to include the adjoint of the matrix L, and then we simply multiplying the two parts. So from there we are going to say L inverse is equal to 1 over, so we substitute for determinant of L, we have it's negative 2. Then we are going to multiply this by the adjoint. So what is the adjoint of the matrix L? So the adjoint is the matrix that is formed when we interchange. For the major diagonal, we interchange the positions of the elements, and then for the minor diagonal, the signs are going to change. For the element which is a negative number, it changes to positive, and the one which is a positive one changes to the negative. So that is about the adjoint of the matrix. So let's continue. So adjoint of L in this case is going to be 7 here, then negative 2, and then negative 6, positive 2. That is what we are going to have. And then from there, we can now simplify. So L inverse is equal to, so 1 over negative 2, we need to understand that it is a scalar which is multiplying every element inside of the matrix. So this is going to be multiplied throughout. We just rewrite this, and then this we are going to say is the same as negative 1 over 2 times 7, and then negative 1 over 2 times 2, then negative 1 over 2 times negative 6, then negative 1 over 2 times negative 2. We can close. Okay. So from there, we can simplify, and this is going to give us, we just open the matrix. So when we multiply, we are going to get negative 7 over 2. Here, we're going to get a positive 3. There, we get a negative 1. And then here, we get a positive 1. And this is going to be the solution to the second part. I'll see you in the next one.